Example 2. Alan wants to buy a tractor for his vineyard in Stellenbosch. He buys a pre-owned tractor at a cost of 60,000 rand. He estimates its useful life to be 10 years, but intends to replace it in 4 years from now. If Alan wants to use straight-line depreciation, what would be the rate of depreciation per annum? Using straight-line depreciation, calculate the book value of the tractor at the end of 4 years. Calculate the expected cost of replacing the tractor in 4 years if he expects the inflation to be at the rate of 5.4% per annum. He sets up a sinking fund and deposits 6,500 rand every 6 months, starting in 1 year's time and ending 1 year before he replaces the tractor. The interest rate for money in the fund is 12% per annum, compounded quarterly. Calculate how much money will be in the sinking fund at the end of 4 years. At the end of 4 years, if Alan sells the old tractor at its book value and uses the money in sinking fund, does he have sufficient money to replace the old tractor? Show all calculations. Solution. Let us note down the given data. Cost of tractor, P equals 60,000. Estimated useful life, N equals 10 years. Observe carefully that we have given the estimated useful life as well as the time by when Alan intends to replace the tractor. For calculating depreciation, we need to consider the estimated useful life. Recall the formula for calculating depreciation under straight-line method. Alan thus intends to replace the tractor before the end of its useful life and use the cash obtained from resale to fund his purchase of the new tractor. Substituting the values of P and N, we get. Using this value, we can now calculate the rate of depreciation per annum. Recall that in straight-line method, value of depreciation is calculated as a percentage of the original value or the principal. Making I the subject of the formula, we get I equals 10%. Therefore, the rate of depreciation is 10% per annum using straight-line method. Recall the formula for calculating the book value under straight-line depreciation. Substituting the values of P, I, and N, we get Therefore, the book value of the tractor at the end of 4 years is 36,000 rand. We have been given the rate of inflation, which is the average increase in price of tractor each year. We can use the compound growth formula for calculating the price of the tractor at the end of 4 years. Using the rate of inflation for appreciating the value of tractor, we get Therefore, the cost of replacing the tractor will be 74,048 rand and 6 cents. We can see that Alan is making a series of payments into the same account, which is the sinking fund. We need to calculate the future value of these payments as Alan is saving up to replace his old tractor. The payments are starting in 1 year's time and ending 1 year before he replaces the tractor. Hence, let us make use of a timeline to calculate the time periods and the number of payments accurately. Since the payments are being made every 6 months, let us denote those points in time in the timeline. Now, let us read the problem again carefully. Deposits 6,500 rand every 6 months, starting in 1 year's time. So, the first payment will be 1 year from now, which is denoted by T1 in the timeline. The deposit is made every 6 months and stops 1 year before he replaces the tractor. We know that he plans to replace the tractor in 4 years. So, we can continue to make the deposits every 6 months until T3. We note the interest rate for the sinking fund below the timeline. We now need to calculate the period for which each deposit stays in the sinking fund and earns interest. Note that although the deposits end at T3, we need to determine the future value of each of the deposits at T4, when Alan intends to replace the tractor. Note that the interest rate is compounded on a quarterly basis. However, the deposits are made semi-annually, that is, every 6 months. Since the frequency of deposits, every 6 months, and the compounding frequency, quarterly, are not the same, we cannot directly apply the formula for future value annuity. Hence, we will calculate the future value of each of the deposits to calculate the sum of money in the sinking fund. We will start with the last deposit and write down the future value for each deposit and set up the equation. Recall the formula for compound interest. We can see that Alan makes 5 deposits. The 5th deposit, made at T3, earns interest for a period of 1 year, that is 4 quarters. The 4th deposit earns interest for 1,5 years, that is 1,5 times 4 quarters. The 3rd deposit earns interest for 2 years, that is 2 times 4 quarters. We continue in this manner until the 1st deposit. Look, this forms a geometric series, where the first term, A equals 6,500, times 1 plus 0,03 to the power 1 times 4, and R equals 1 plus 0,03 to the power 2, and N equals 5. Sum of the geometric series is given by A equals A times R to the power N minus 1 over R minus 1. Substituting the values of A, R, and N in the equation, we get Therefore, the value of the sinking fund will be 41,314,055 Rand at the end of 4 years. We know from C that the cost of replacing the tractor will be 74,048 Rand and 6 cents. We know from B the book value of the old tractor at the end of 4 years will be 36,000 Rand. We also know from D that money in the sinking fund at the end of 4 years will be 41,314,055 Rand. At the end of 4 years, if Alan sells the old tractor at its book value and uses the money in the sinking fund, he will have A equals 36,000 plus 41,314,055 equals 77,314,055 Rand. This is more than the cost of replacing the tractor, which is 74,048 Rand and 6 cents. Hence, Alan has sufficient money to replace the tractor at the end of 4 years.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.